Hi everyone, welcome to Skilled Inspirational Academy. As you see my screen, today's topic is Wireshark training. And a little bit background about myself. My name is Arjun. I'm working as a network engineer. And my responsibilities is to take care of the Cisco network appliances and wireless devices. I've been working in the same domain for past 10 years. So I'm carrying 10 years of experience in networking. So I would say the biggest takeaway of this class, what you would get once you finish this training, the biggest takeaway from this class is that you would understand Wireshark with more insights. And there are many people they still not aware of Wireshark, and Wireshark is very powerful network analysis tool. So by end of this training, you understand Wireshark with more insights about TCP and other most common used protocols. And also, by end of this class, you would be confident to confident, and you will be very skillful to filter out the packets in Wireshark, and you would get really a solid understanding of TCP. And also you would able to troubleshoot your TCP and network issues once you finish this training. So that is the biggest takeaway from this class. So let's start this. Yeah. So for networking, the most common problem, if most of the time the network engineer they would be facing is the internet slowness issue. So all the team members, they'll be always barking about this problem. Either it could be a application issue, it can be a server issue, but it always, the network team will be blamed for the slowness internet connection, right? This is the most common issue we would know. So let's get started with this. So when you get a problem, generally what the network engineers, the conventional way of doing troubleshooting, what they do. So when the problem comes to the networking team, so they have access to, most commonly they use routers and switches. We all aware of it. So that's the appliances they use. And they say it is a layer 2 and layer 3 devices. As you know, this is OSI model. We say this is OSI model. And they mostly work on this layer 2 and layer 3. So the router is the appliance, it works on IP. So it is called layer 3 because it uses IP address for communication. Layer 2 is MAC address and all your switches work on it. So I'm just giving a glimpse about this. So the maximum possibility what we have, the network engineer we have, is to check the physical connection first. Example, if you got 2 routers here, and if the physical connection is broken, or if you got any errors here, so you can check all this in your CLI. In the command line, you can see the errors are increasing, and so you can see your errors are increasing. Yeah, your errors, CRC errors. So this is possible with CLI. But what if there is a problem with the application? How do you prove? So here comes a debate between other team and the network team, right? So they say, okay, if I have checked everything, my network interface is clean, my utilization level is quite normal. It's not, the bandwidth is not choking, it is below 60%, and there is no error. But how can I prove it is a network issue? So that is the biggest challenge we have. So how to deal this problem? So to understand that better, I'll give a glimpse about what is TCP IP. So what is the agenda of this class? So if example, if there is a packet loss, how do I find? Okay, with all the availability, with the interface errors and all that, I have done all the checks, but still I couldn't figure out it's a problem with network. I'm a bit doubt about this. Maybe it could be a problem on my end, but my possibility is to check all this, but I did all this. But apart from that, how I can leverage this to the next level and to find how do I do a deep packet analysis and find out it is not a network problem, it is something with the application. How do I prove that? So here comes the challenge, right? So the most common problem when it comes to network performance is packet loss, right? If you see a packet loss, but how do I find it's a packet loss, and who is where the packet loss happens? Is it in the source or a destination? It can be either a source or destination. So how to diagnose and fix it? So before going to that, I'll want to give a glimpse about TCP and IP. So you all heard of it, but I'm not going too deep about TCP IP here, but I'm giving an idea of how TCP IP works here. So TCP, they say it's a transmission control protocol and it is reliable. Whereas with UDP, it is not like that. So why it is called as a reliable? So every packets it's received on the other end, it's going to send an acknowledgement for every single packet. So what is the advantage of this? If I miss any packet in the middle, so it's going to say, the destination is going to say that I didn't receive the packet, so you have to resend back. So that's called retransmission. So you have to retransmit the data because I haven't received it. And we all know that if you send a 1 MB of file and it is not the 1 MB file will not be sent it across as a one whole file, right? So that's chunks of data. So that's segmented into packets and it will be sent as a one by one. Packet 1, packet 2, packet 3 example. So if there is a problem with packet 3, it's going to acknowledge that I didn't receive packet 3. Can you send it back the packet 3? So this is a real advantage of TCP, whereas the UDP doesn't work. Once the connection is established, it's going to send the data continuously. It never bother about whether it's been sent successfully or it's a failure. It doesn't care about anything. It just continues to send this data. So your YouTube, most of the video streaming application, they use UDP. So this is the key difference between TCP and UDP. So here, if you see, if there is a computer, if you want to send a data, it sends us a small chunks before transfer. It's not the whole data. So with the help of TCP, what is the real advantage of TCP? The successful transfer is being acknowledged. But whereas in the physical network, this is not guaranteed, right? So if I have only access to my routers and switches, but how do I see all this? I cannot see all this information. So I can see only the interface errors and the physical problems I can figure out. But this is something, the segment level of analysis I cannot do with my appliances. So here comes the Wireshark. So how can I use a Wireshark to figure out all this and how I can filter all the protocols and I can do a deep packet analysis. So example here, if I send a packets with numbering, so does it mean that the packet delivery is successful? No, definitely not. So that's the reason the TCP is using the acknowledgement number and sequence number. This is again a glimpse, not too deep about this. So when we say TCP is a three-way handshake, whereas in UDP, it is not. So if you see, this is a three-way handshake. So this is a source, your PC. It's going to send a sync. So before your data transfer, the connection establishment should happen. So it means that if the PC sends a sync to the destination should respond back with sync acknowledgement. It says that, okay, I got your sync and an acknowledged. So for the sync acknowledgement, it's going to send an acknowledgement back again. So this is called three-way handshake. So it's fine. So we understood that the connection establishment should happen before your data transfer. That is a real advantage of TCP, whereas in UDP, it is not. So now we have gone through, how TCP, we got a basic understanding of how TCP works and what is three-way handshake and what is reliability and all that. So this is very basic. So what is sequence number and what is acknowledgement number? This is important. So whenever the conversation starts between source and destination, it's going to start with a sequence number. That's like, marking your packets. So every packet has its own sequence number. If you see here, this is a source. This is a random port number, right? Can you see this? This is a 4016. So you can find this is a random port generated by your Windows PC. And this is from the client. So I can say this is a client by looking into the source port numbers, and destination port is 80. And this is a server. How can I say it's a server? Because port 80 is HTTP, right? So this is a server. So it is trying to establish a connection. So this is a server back. See, now the source port is changed to 80. So earlier it was source is 4016 and destination is 80. This is source and this is destination. So here again, this is source. This becomes source because this is a server. And the destination port becomes 4016. This is your client. So this is a glimpse about how TCP sequence number and acknowledgement works. And now we go to the hands-on practical demonstration to find the TCP IP troubleshooting part. Okay, so let me open up this. So my objective here is to find only DNS. So there is a connection establishment happened. Example, you're trying to access google.com. So it sends a DNS request. This is for name resolution, right? And for the name resolution, it uses DNS. But in my packet capture, how do I find the DNS request alone? So I want to see how many DNS requests has been sent from my PC. So this is lab capture. So now this is the display filter. If you actually see this is the, let me maximize my screen. So this is the tool called Wireshark, and you can know about the version of it. This is version 4.0.3. And we'll see the list of options that's available. But what is the key options we have? Let me explain. So we don't want to bother about time, delta time. So we are just looking at the basic understanding of Wireshark here. So I did a capture and I've opened up the capture here. So here is a display filter where you can filter your protocols. So here I want to see DNS. So if I click DNS, I have to look at the displayed value here. So what is my displayed values? 606. So I got 606 DNS packets in my capture. Right? I can see here protocol is DNS. You are looking only DNS. If I delete this, if I remove this filter, I can see all the protocols, not only DNS. I can see TCP, HTTPS, and all other protocols. But I'm not interested in all that. I want to see only the DNS conversation that happened between my PC and to the destinations. So to do that, so here is an option is a display filter value. So here I have to type DNS, enter, that's it. So I get all the DNS. So how many DNS packets I got? I got 606 DNS packets here. So I got 606 DNS packets. So now I want to see, we all know about query, but this is again the basic understanding of query. So when you type google.com, what exactly happened in the background? So if you type google.com in your browser, I don't know about who is google.com. I don't know about anything. We all know this works only based on IP addressing, right? It works only based on IP addressing. So I don't know the IP address of google.com. This is unknown. So what it does, it sends a DNS request to the DNS server. So my PC points to Google DNS 8.8.8.8. We're all aware of this is root server. So my request goes to 8.8.8 and my PC is asking for who is google.com and what is an IP address. Example, I'm giving a private address here. It's 8.8.4.4. Example. So I got this address. So this is called as a query process. See, can you see this is all query process? It goes here. If you drill down this packet, you can see it's using DNS. This is a query. This is my source port. And this is destination port. So what is this? Is a DNS port number 53. And this is UDP. It is using UDP. So we'll get to know about all this. So if somebody is asking that your DNS is not working, you can do this. You can do a capture and you can see it is really happening or not. So from here, what is the query it says? So this is an host A record and this is www.google.com. So this is how you can filter out the DNS in Wireshark. So now we are moving to the next one. So I want to see how many queries has been done from my PC, how many DNS queries has been sent. To do that, I'm going to delete this filter. I'm going to apply this. So I got 981 DNS requests, queries has been sent. So all standard queries. If you see this, it goes to spxflow.com, youtube.com, cloudflare.net, Mozilla, and you can see all the domains. Wherever the query has been sent from your PC, you can drill down. And if you're interested on a specific query, you can go and see what really happened here. You get a query response back, then your DNS is success. If you're not getting it, then it is a problem, something with your source or destination. So we'll get deep understanding about the DNS queries here. So what is the total number of DNS packets here? It's 981. So I got 981 queries. Sorry. So I got 981 queries has been sent from my PC. So if I am interested to filter out only the query which has been sent to google.com, how do I do that? To copy this, filter dns.query.name equal to the domain. For example, it can be youtube.com or whatever the domain you want to filter, you can do it. But this is the standard filter, that is dns.query equal and your domain name. Here, I want to filter out only google.com. I can see google.com. Only google.com here, not any other domains. So how many requests has been sent? 4 requests. So you got 9,851 packets, but the display value is 4. It means that only 4 queries has been sent for google.com because I filter out very specifically for google.com, the domain only for google.com. So the displayed value is 4. So total queries are 4. So 4 queries has been sent. Now, I got about 9,851 packets, but somebody is saying, okay, I got a problem with my TCP. But how can I figure out that? So to do that, you just go and type TCP in the display filter, and you will get only TCP. And we all know that TLS HTTPS is on top of TCP. That's why you can see TCP and TLS together. So how many TCP packets I got here? So out of 9,851 packets, the only TCP packets are 7,988. So 7,988 packets, only TCP. So to find how many UDP packets, I'm not interested on any other packets, and how do I find UDP? So this shows only UDP. Because here it shows MDNS uses UDP. We have seen that. The user datagram protocol, it uses port number 53. So you see MDNS along with that, because whatever the protocols it uses DNS, it's going to show up here. So out of 9,851 packets, I got only 1,752 packets. Only DNS. Sorry, only UDP. So in the same way, we know about ICMP, right? So ICMP, let me give you a glimpse about ICMP. So this is my source, and this is my destination. So the ICMP will send actually the 4 consecutive packets to test the connection. This is called ICMP request. ICMP response. So ICMP request will be sent by the source, and this is sent by the destination. If for my ICMP request, if I get an ICMP response, then the connection, then I have a connection between source and destination. And if I am not getting ICMP response, then there is something problem with my destination. But how do I find that in Wireshark? You have to go erase this filter, and I have to type ICMP. Can you see this? This is ping request. This is all requests sent from the source. This is my IP address, 192.168.0.38. This is my IP. My PC is trying to communicate with this destination. This is ping request. And if you see the ping reply, this is the destination. It is sending a reply back to my source. This is ping reply. So from this, you can figure out, see, this is all port unreachable, right? So if I send from my PC, I'm trying to communicate to this destination, it says destination unreachable, port unreachable. So it means that there is some problem with my destination. You can see multiple destinations, all public IP addresses, it's all destination unreachable. So from this, I can figure out this too has communication for sure, because I see ping request and ping reply back, whereas I cannot see the ping reply from the destination, from the public IP. See, my source is sending packet, but I'm not reaching the destination, port unreachable. So it says there's something problem with all these IP address. This is all destination unreachable. So you can say, now I don't have any problem with my network. It is something problem with the destination. So you will get the solid understanding. You have a solid proof that your part is fine. You don't see any problem from the network standpoint. It's something problem with the destination. You can prove that with the filters. So in the ICMP, if I look at here, out of 9,851 packets, the displayed value is 21. So only the 21 ICMP conversation happened. So 27. So what if, example, I want to look at all the traffic, but I don't want TCP traffic. I'm not interested in TCP traffic. Somebody is saying, oh, I want to ignore the TCP traffic because there is something problem with other protocol, my DNS, maybe my ICMP, whatever protocol, but I don't want the TCP packet. How to do that? So you have to give exclamation and TCP. If you give that, you're going to see all the protocols except TCP. You see all DNS, ARC packets, your ICMP, right? You see all the protocols, but not TCP. So 1863 packets except TCP. So all the protocols are included in this 1863 packets, but no TCP packets. Total, I got 1863. So I don't want ICMP packets. The same filter you have to add. This is also called as not ICMP, exclamation ICMP. So what is the meaning of it? It's not ICMP. If you give not ICMP, you're not going to look at the ICMP packets here. So 9830, but not ICMP. It includes all the protocols. So now I'm interested to see, I don't want to see DNS, I don't want to see ICMP. I'm interested to see TCP and all other protocols, but not UDP. So now you cannot see any UDP because I gave exclamation UDP. It means that I want TCP and not UDP. And you see only TCP conversation here. So how many packets is 7,988? Okay, now we got to know how I can filter the TCP, DNS, UDP, and I got an idea about all this. So now let's go for a scenario. Example, you got a problem where you have a network loop. But as I said, with just the CLI and the monitoring application you have, you cannot rule out, or you cannot concretely say it is a network loop or you don't have any problem. But what is the proof, and how do I do that deep analysis and deep dive and find out, okay, there is a network loop, or my network is very clean? So how do you prove that? So to do that, I have a packet capture. That's a lab capture I did. This is a use case to find there is a network loop. So to do that, I have to type TCP first. We all know. So I'm just looking at the TCP conversation now. So here, let me start with from here. So here, if you see, this is source port, and this is destination port. This is HTTPS because HTTPS uses 443. You cannot see all this in your router, right? Maybe in the firewall, you get to know what is the active connection, what is the protocol used, but just with routers and switches. If you have Wireshark, you can see all the port numbers, and what is the protocol used, and your TCP handshake, and even more. We'll see that. So now we got source port number. This is my random generated port number for my PC. This is my private IP address. And this is my public IP address. And this is my public IP. So when I look at this, we discussed about this, right? From the source to the destination, SYN. So from the destination, I'll get a SYN back. It means it says that I got your SYN and I'm acknowledging you. So for this SYN it's going to send a sync again. This is a conversation between source and destination. So now I know from this Wireshark, I have taken out these values. This is my source port number. And what is my destination port number? It is 443. And based on the port number, I know this is HTTPS connection. So here TLS is used. We all know TLS uses HTTPS. It's running on top of that, right? So you see this client hello, cipher sec exchange, the certificate exchange. This is 2D, but I'm just giving a glimpse of it is using HTTPS and we are using TLS. That's why the handshake, you all see all this information, only possible with Wireshark. So I get to know about all these details. So now how do I find it's a problem with the network? How do I figure out that? Okay, so for that, first we have to see the basics. So I see SYNAC. So it means that my connection establishment is successful. Agree? Yes. My connection established. So what is the problem now? My connection is established, but how do I find out there is a network problem? If you drill down, you can see the errors. Okay, what is the first error I see? It says retransmission. So now we have to look closer. So who is sending this? So this is the destination port. From the random port number, I have figured out that, okay, I know this is client. And from the source port, this is HTTPS, only the server uses it. So I know this is server port. I know this is server. If you drill down even more, so you see that retransmission TCP segment data. And if you drill down this sequence and acknowledgement analysis, there is an analysis flag set here. It says this frame is a suspected retransmission. So why retransmission happens? It says, I didn't get this packet. Can you retransmit back again? Send it back one more time because I didn't receive it. So here the retransmission happened. You can find that under the TCP analysis flag, and expert info will give you this detail. So here the retransmission happened. And who is doing this retransmission? I have to find out, is it the problem with the client or server? But from this, I cannot figure out. So I have to do a deep packet analysis. So one retransmission happened, that from the server to the client. So if I do a drill down, so I have to look at any other errors, TCP errors. Okay. Can you see this? It says TCP out of order. What is the meaning of TCP out of order? Example. So this is my source. This is my destination. We all know this is not a one-to-one communication. There are service providers in the middle who gives an internet connection for me. So I have a redundant connection. That's my ideology to say here. So I have a redundant connection to it from my source to destination. So the TCP, it says it's out of order. What is the meaning of it? So if my source and destination is communicating in one single path, if the communication is happening only between these two paths, if it is going across this router 4 hops away, and if I'm reaching this destination, I won't see this out of order. The TCP out of order, what generally it says, so when I send a packet from source to destination, it goes to this primary path, router 1, router 2, and router 3, and it reaches a destination here. So when it comes back, it's actually coming back with router 6, router 5, and router 4. So this is taking this path instead of this path. So this is called a route. This is a loop in a network, right? So I got 2 paths. This is not good. I should have the bidirection should happen in one single linear path. It should not happen like this. Then there is a loop. Because of this loop, the network is completely confused and I don't know where to send back this request back. So for the first time, it's going to send in the primary path. A to B. It's going through router 1, 2, and 3. But when it is coming back, it is coming through R6, R5, and R4. It's taking a longest path instead of coming back in the same. But this is for a demonstration. I have given only 4 routers. There can be hundreds of routers in the middle. We all know that the ISP is all interconnected. They do this BGP pairing and they do all this. And this is not guaranteed that I'm getting a reply back from the same place. So where exactly this has happened? So if I look at that, if you see that first retransmission, when we looked in the very first place, when we saw this retransmission, it is from the destination, from the server. If you see the TCP out of order, it's been generated only on the destination, that's the server. So it means that my problem is with the server, not with the client. If you see, all this out of order has been sent from this. So about how do I filter out only this? I have to go to conversation filter, or you have to right click and you have to go to conversation filter and you have to do TCP. And you see only this conversation. You got 10 and 20 TCP conversations. But I am interested in one single conversation. And you can see this is the destination, this is a source, this is a server, and it says TCP out of order. If you see the acknowledgement number and sequence number, they are all unique. So here is a network loop. How this is possible? Only through Wireshark. You cannot do this with your appliances. You cannot with CLI. You do not have this kind of deep insights about what exactly happened between this TCP IP conversation. So now we found, okay, what is the meaning of TCP out of order? It means that there is a loop in a network. So what are the other key things you have to see here? See, this is all non-routed packets. I can definitely say this is time to live all with 64. So we all know this is the standard. They say it's a TTL value. For Unix, it is 64. 64 is 64 hops. And for Cisco routers, it is 255. And for Windows, I believe it should be 255. So why TTL is so important here? Do I really concern about TTL? Definitely. Because every hop that will be decremented. Example, if my packet is going from R1 to R3, so for every hop, the TTL value will be decremented by 1. So here, if you see, these packets are not routed at all. If you see the sequence number, it's going to be the same. So here, no routing happened here. There is a problem with the connection. That's what I mean to say. So in my whole conversation between source and destination, there is a place where I'm not getting a response back. So why? Because it's going in a 2 different path. There is a routing loop. And if you actually see here, this is all taking 2 seconds. 2 seconds in a network is a high latency. It's all happening in milliseconds. And the routing is not happening. So I can confidently say it is a problem, and it is a problem with the destination. Right? For this request, I'm not getting a response back at all from the destination. So it means that my packets are not routed. It's not moving forward. It got stuck in one place because of this routing loop. At times it works, at times it is not. So we say this is an intermittent issue, right? And there is a slowness in the network. The network path is not, properly optimized or designed. So I have to look at routing. So from here, you can take it, you can leverage your troubleshooting further. So now I found there is a loop, but how do I find that? So I'll do a trace route from my command prompt to the destination, example 8.8.8. So it's going to show me 2 different paths. Example, if I want to reach 8.8.1, example, I am going to 192.168.1.1, my modem router. Then it goes to public, example, 113.4.5.6, 113.4.5.8, and then I reach 8.8.8. But when I do the same thing in the destination, example, this is happening inside your network. I mean, this is inside your enterprise network. This is not in the cloud, I'm saying, but because the cloud they have a load balancing, and you may see a different path. But I'm talking about only your branch office and remote office connection, something like this. Only between your branch office and your remote office, a connection, something like this. This is all branch office, and this is your headquarters example. So I'm just talking about the communication between your branch office and the headquarters. And if you do a trace routing, you will get a different response. Here it is taking the IP address, whatever you see here, but when the reply comes back, you see a different value. Example, you see here 114.4.5.8, but it's again reaches 8.8.8, but that is not expected. If your path is optimized, you have to get a reply back in the same path. It has to take the same path. Then it is a routing loop, and definitely there will be a latency, and there is a performance issue. So you have to figure out this. How I come to know about all this? Only because of Wireshark. Wireshark gives the complete insight about the issue. You cannot do that only with router CLI. You can do a trace route, but how can you find this TCP out of order and TCP retransmission and acknowledgement numbers? So all this information is only available in the Wireshark, and you can make use of this tool. And so many people, they use this the architects, they use this tool to figure out the problem. If there is a problem continuously and we cannot figure out, so they come in and they do all this packet analysis, and they'll figure out it's a problem with the network, or it's a problem with the application, it's a problem with the server. So now I say this is a server because the server is keep retransmitting here, but anyway, my path is not optimized. So it's my problem. So once I fix this problem, still I encounter this problem, then there is a problem with the server. So now let's see TCP retransmissions. Let me take out this filter. So I want to see only retransmissions. So conversation filter, TCP. If I drill down, you can see the fast retransmissions, duplicate acknowledgments. Yep. So here is a scenario. So now if there is a problem with the client, now the server is fine. Now there is a problem with the client. So how do I find that? So here you see the TCP duplicate acknowledgements. Why it is a duplicate acknowledgement happens? Let me once again do this. So this is again source. And this is destination. Sorry for that. Let me delete this. This is my source and this is my destination. The same way, my three-way handshake is successful. Yeah, my connection established. This is the phase where your connection is established. What is the next step? It's a payload. It's your actual data. So here I see a lot of TCP duplicate acknowledgement along with retransmission. So if you actually see this, see here again, from the time to live, my packets are not routed. So here the actual retransmission happens because it says, see, here I have no connection. It proves I have no connection. It keeps sending duplicate acknowledgement because I don't have network. My network is down. From the source, there is no network connection to the destination. So I have something problem with my network here. So I keep sending this duplicate acknowledgement. And finally, here it happened because congestion, because of latency. See here, no actual payload. It's all your TCP segment length. So my TCP segment length is 0. It means that no data has been transferred across. So it's keep asking me, I did get the packet. Can you send it back again? So it's going to keep on sending the acknowledgement until I get a retransmission back. So this is how you can, rule out your issues. So the very fast way of finding the problem, instead of scratching your head for a long time and you have no clue of where the problem is, with the help of Wireshark and with the proper filters. So I didn't apply any filter on top of this. If I just follow the conversation, TCP conversation, you can see the filter has been auto-populated right back here. So it says this is my source port, right? 61918. And this is my destination port server. And this is a server IP address. And this is a client IP address. So I get to know about all this. Just I have to do is apply filter, conversation filter, and do TCP, and you'll get this here right away. With the help of filters, this is very, very minimal amount of finding errors. You will find, you have a lot of errors that you encounter every day, but you have no clue of what exactly happening in the background. But with the help of Wireshark, you will get to know how to rule out this issue. So if you're familiar with Wireshark, then it is a cakewalk for you to find out the problems in your network. So this is all about Wireshark and TCP IP. And I hope that everybody, they got more understanding about TCP IP and what is TCP out of order, what is retransmission, what is this three-way handshake, and how do I apply filters in Wireshark. So in the real classes, you will get more scenarios, more troubleshooting, more hands-on, and you will go deep about every single protocol. So now we got a glimpse about what is DNS and how this DNS query happening. And if we want to find out why the DNS query, who is not sending a response back for my DNS query, is it a source or destination, or if it is a TLS handshake, where is the problem? Is it a problem with the server or client? Is it a problem with the certificate? So you will get to know about all that. You will get the complete insight, and you can decode everything with the help of Wireshark. So this is all about this Wireshark webinar. And I hope that everybody would understand, and they got a solid understanding, at least a basic solid understanding about TCP and what is the use of Wireshark and how you can filter the packets using Wireshark. So now I'm going to unmute everyone, and you can ask your questions.
Hello.
Yeah, hello.
So my question is, suppose the communication like that's SSL handshake.
Yeah.
Like source IP is my like 10.40.40.10 server.
Okay.
And destination my is 172.20.20.10.
Okay.
And how we can check the SSL handshake is complete or not complete?
Okay, so example, if you look at here, let me drill out this. Okay, let me put this as a TCP. Okay, so see, if you actually see this is client hello, and this is server hello. So if I get a server hello, server is responding back, right? So if I get a server hello, the connection establishment is successful. And then again, once the client and server hello happens, here exactly your security handshake happens. And here, if you see your actual data, it's been sent it across. Here it's actual payload happens here. But the client hello and server hello should be successful. Only then the security handshake happens, and then your actual data payload will be sent from the source to destination.
Okay. And what is the next parameter we can check? SSL handshake.
No,
Suppose
if
one packet you can open,
Mhm.
like we normally we have checked source IP, destination IP,
Yeah,
protocol number,
yeah,
three-way handshake, TCP sync.
yeah.
For SSL, what is the next? What is the extra parameter we can check?
No. If
Like-
if what I'm saying is, see, if your client for your client hello, you got your server hello, it means that you got the server hello back. It means that the connection is successful. Then it's exchanging the security. No, the security handshake happens here. So if this cyberspec happens here, your actual data transfer is happening. So that's it. If you are at this place, then your connection is established successfully. There is no problem with your communication here. If I'm not getting a server hello, then it is a problem with the server.
Okay.
Right. So but here I got the server hello, but we have to do a use case where we have to, you have to make some problem with your server, and the server should not respond back. You should turn off your server, or you should give a wrong IP assignment, something like that. So you cannot get a server hello back. Then you can find out it's a problem if the server is not responding. Maybe the server is down, or maybe something problem with the server certificates. Example, if you get server hello and this change cipher, there is a problem with this change cipher. If there is an error here, then you can say it's a problem. Who is doing that? So where the change cipher error happening? Is it on the server or client? So it depends. It depends on the scenario. You have to replicate the issue. Only then we can figure out it's a problem with a client or server.